We'll now take a look at solving quadratic equations. This is a topic we began back in assignment 2, and now we're going to finish it in assignment 3. Quick reminder of what a quadratic equation is. Essentially, it's an equation with an x squared in it. You won't see things like x cubed or x fourth because those are higher order equations. You also don't see variables in the denominator. You don't see variables inside radicals. Those are different types of equations requiring different types of techniques. All right, in this course, we're covering 3 methods for solving quadratic equations. The first method listed here is factoring. We already dealt with that back in assignment 2. Now in this video, we're going to focus in on the square root property, and that occurs in the notes on pages 291 through 297. In the next video, I'll deal with the quadratic formula, and that's in the notes on pages 298 through 304. Quick comment or two about these 3 methods in general. One natural question to ask is, which method should I use? Well, I guess the natural answer to that question would be whichever is easiest, whichever seems most reliable. What does that boil down to? Well, here's what my advice about that. My advice is to take a look at factoring or the square root property first. See if one of those 2 methods might be an easy way to work the problem, because if so, that's going to be the easiest way to work the problem. Now, what about the quadratic formula? I consider that the method of last resort. Yeah, it can solve any quadratic equation out there, but often it's more complicated than you need to do. That is, factoring our square root property might be an easier way to go. But if the first 2 methods here don't seem like they're going to work out, fine, use the quadratic formula. Just don't run to it first thing on every problem. That tends to be rather inefficient. The other thing worth mentioning here is that you don't have to worry about checking your solutions. Now that issue came up when we cleared denominators and when we did something like square both sides. But these methods, you don't have to worry about that. As long as you don't make an arithmetic mistake, you should be fine. Your answer is going to work out just fine. You don't have to worry about doing a check. Okay, so let's take a look at some examples of the square root property. We'll begin by taking a look at what the idea is for the square root property. And it's a pretty simple idea. In fact, that's why the method tends to be so easy to carry out. At least relative to the other methods, the square root property is probably the easiest of the 3 methods to do. So if you have a choice and the square root property is among those choices, I would take it every time. Now, how does it work? Well, basically it says if you have an equation of the form x squared equals a number, then to solve the equation to get x equals something, you just take the square root of both sides. So the square goes away on the x, and then the k, as you can see, goes inside the square root. Notice how there is a plus minus in front of that square root. That's because every number actually has 2 square roots. There's a positive square root and a negative square root. Think about what 2 numbers can you square to get the number 9? Well, you can square a positive 3 to get a 9. You can square a negative 3 to get a 9. Those 2 numbers, plus and minus 3, are the 2 square roots of the number 9. So you got to have plus or minus in front of the square root to get all the solutions to the equation. All right, let's do some examples here. And I won't do all the examples I have in the notes just because it'd take forever to do that. But we can cover a few. Let's start with the first one here. X squared minus 9 equals 0. Now, you could easily solve this equation by factoring. It would not be difficult to do. It's a difference of 2 squares. It'd factor pretty quickly, and you'd be done very quickly. What about the square root property? It's just as fast and just as easy, maybe even more so. How do you do it? Well, you got to make your equation have this format, x squared equals a number. So how does that work? Well, move the 9 over, which is not too hard to do. Just add it to their side. Then, you see we have the format here. Just take the square root of both sides. And of course, there's the plus minus. The square root of 9 is just a 3, so there's your answer, plus or minus 3. Now, how do you write that? Well, my favorite way of writing it would probably be the most compact way to do it, plus or minus 3. Sometimes they'll do that. Are there other options here? Sure, 3 and negative 3 be an option. What about, say, negative 3 and 3? Those are all good. It doesn't matter. There's no ordering here. This is not an interval. You're just saying I've got 2 numbers that solve the equation. One of them is 3, one of them is negative 3. All right, let's move on to something a little more interesting than this because that was pretty easy. Can we make the equations a little more complicated? You bet. Let's do a couple more here, a little more interesting, and then we'll move on to the quadratic formula for the next video. All right, let me take a look at the next example or 2 that we have here. Yeah, it's a better one. Try this guy here. 4m squared plus 17 equals 26. All right. Now, again, to use the square root property, you have to get the m squared by itself. Not too difficult to do, as you can see. Just isolate it by moving the 17 over first. All right, so 26 minus 17 is going to be a 9 there. And then divide both sides by 4. There you are. Now just take the square root of both sides. And of course the square root of 9/4 is 3/2. Voila. Not too bad. You can see the square root property does its thing very well, very efficiently. That's why I like it so much. Unfortunately, you can't use it all the time because some equations it won't work on. And that's why you have things like the quadratic formula. All right, let's move on to another example. Can we make it a little more difficult than that? I suppose so. Let's see what we got here. How about, oh yeah, let's do this guy here. Yeah, that's not too bad. It's very similar to the last one, but a little trickier toward the end there. 5r squared plus 13 equals 15. So like the previous problem, we're going to get the r squared by itself. That's not too hard to do. So let's move the 13 over to get started with that. That gives us 5r squared equals 2. Then divide both sides by 5. Now we got the r squared by itself. And like we did on the last problem, let's take the square root of both sides. All right. Now, you could have that as your answer. Nothing wrong with that answer, but sometimes what they'll do is they'll take this thing and rationalize the denominator with it. That's what makes this problem a little more complicated, I guess, than the last one. Because the last one had a very nice square root. This one's not quite so nice. So remember how to rationalize the denominator for a problem like this. It's not too hard to do. Square root of 2/5. You got to break it up into two separate radicals first. There we go. And then you multiply top and bottom of it by, what in this case, square root of 5? Yeah, that's right. So multiply top and bottom by square root of 5 to rationalize. And there we are. Now you got the square root of 10 over 5. All right, so you can leave your answer like this up here, or they could rationalize the denominator with it, and that would basically give you plus or minus square root of 10 over 5. There's nothing to say that one of these is better than the other. If I was to give an analogy for what's going on here, it would be something like saying which answer is better, 11/3 or 3 2/3. And they're the same value, so is there one better than the other? Not really. This is the improper fraction, that's the mixed format, and for various reasons they might prefer one over the other, but they're both good in a sense. They're both in lowest terms, that sort of thing. Same thing here. Rationalized denominator is not a hard and fast rule that really matters. If you don't see this, then look for the rationalized denominator version of the answer. All right, let's move on from there. This next one's going to be a little different, I suppose. Still using the square root property, but a little different in appearance. At first here, let's see. Here we go. X minus 5 squared equals 49. It works the same way, even though it doesn't look exactly like the others. Basically, you need to get rid of that square on the parentheses. And you just do that by taking the square root of both sides. So what's that going to look like when you take the square root of both sides? Well, what happens if you take the square root of a thing that's squared? You just get the stuff inside there. Just get x minus 5. I mean, if you were to write that out, it would look something like this. I usually skip that step, but it would look like this, wouldn't it? There's the square root of the thing squared. They're going to cancel out. The square root and the square root cancel, just leaving you the x minus 5 inside. So I usually just jump from the beginning of the problem right down to there. I don't need to write this middle step out here. Now on the right side, that's where you actually see the square root show up with the plus minus in front. There we go. Plus or minus root 49. Of course, the square root of 49 is 7, so let's go ahead and put that there. And then finally, add 5 to both sides. So you basically just go in here and say, all right, got to move that 5 over, add 5 to both sides. There we are. And that's going to look like x equals 5 plus or minus 7. Now there's actually a couple different values there, aren't there? So one of them is going to be what? A 5 plus 7. And the other one's going to be a 5 minus 7. So you got two answers in the end, one of them being 5 plus 7, which is 12, and 5 minus 7, which is negative 2. And that leads to your two solutions to the problem, 12 and negative 2. There you go. Again, not too hard to do. I really like the square root property. It's hard to beat it. All right, let's make it a little more interesting than this. The time remaining, we got get a couple more in here. All right, let's see here. Let's go down to, yeah, that's a pretty good one. 6n minus 2 squared plus 19 equals 83. There we go. This is similar to the last problem, where you got something in parentheses squared. To get started, we got to get that 19 out of the way, though. So you basically have to isolate that squared piece before you take the square root of both sides. So move that 19 over. It's not too hard to do, just subtract it off. And now that you got this squared piece isolated, it's going to be 64 over here. Now take the square root of both sides. So when you take the square of that left side, it cancels out the square, just leaving you the 6n minus 2. There we are. On the right side is where you'll see the square root show up with the plus minus in front of it. Of course, square root of 64 is just an 8. All right. Now, how do you get down to the answer from here? Because this is sometimes where people might get a little stuck, I suppose. Here's my advice on that. Focus getting the n by itself. Isolate that n. So basically add 2 to both sides to get rid of that 2, and then divide both sides with 6. Do that first before you try to figure out what the final answer is going to be. So I'm going to add 2 to both sides here. And that'll give me 6n equals 2 plus or minus 8. Just let that plus or minus ride. Now, get that n by itself, divide both sides by 6. There we go. Now you can figure out what the two values are going to be. That is, you got a 2 plus 8 and a 2 minus 8 on top there. So 2 plus 8 over 6, 2 minus 8 over 6. This will lead you to two solutions. 2 plus 8 over 6 is 10/6, which reduces to 5/3. And then 2 minus 8 over 6 equals negative 6 over 6, which is negative 1. So there's your two solutions. You basically have a 5/3 there and a negative 1. Again, not too bad. All right, make sure I'm still on the screen there. I'm getting off the edge there and double check this. Yep, staying on the screen. This is a little bit off here. Let's try to center that a little better. That looks better. All right, got a couple more I want to try to give you on this video. Here's the next one here. This next one is going to have a slightly messy answer to it because the radical won't go away. And that's what happens sometimes. It just does that. No big deal. That's how some equations tend to be. So you might say they're the more complicated ones. It starts off, though, very similar to the last couple. Looks very similar to them. All right, there we are. 15w plus 12 squared minus 29 equals 43. Like the last problem, you want to focus on getting that squared piece by itself, so we're going to move the 29 over. I'll just go in there and add 29 to both sides. Do that. Alrighty. It's not too hard to do that. What happens now? Well, that means you got 72 over there. Now you take the square root of both sides to get rid of the square on the parentheses there. So just take the square root of both sides. That just gives you the stuff inside. On the right side is where you see the square root show up. Now the square root of 72, this is not a friendly square root. That's what makes this problem a little messier than the last one. The last one's a square root of 64, which is 8. This is not quite so friendly. When you simplify the square root of 72, there's a 36 times 2 in there. So you're going to get a 6 root 2. Or you can do 9 times 8 and then break the 8 down. However you want to do it. You eventually get 6 root 2. Now, like the last problem, focus on getting the variable, in this case the w, all by itself. So get rid of the 12 by subtracting out 12, then divide by 15. Then we'll fiddle with the final answer to get in the format thereafter. So let's move that 12 over there. I'll just subtract off 12 from both sides. All right, that's not too hard to do. All right. And then finally, get rid of the 15, divide both sides by 15. That's pretty straightforward. Okay, now to get the final answer to the problem, you remember those questions, those problems we were looking at a while ago that said simplify the quotient to lowest terms and had to do a little simplifying of the radical and a little factoring and canceling? That's what we have right here. We don't have to worry about the radical. We already took care of that up here, but there is a little bit of factoring and canceling to do. Remember, don't just take out a GCF. That's going to be too much in this case. You want to look at 12, 6, and 15 all together. They all have a 3 in common, don't they? So that's what you want to factor out here, just the 3, not the 6. All right. And then, of course, now you can cancel out the 3 and the 15, leaving a 5 down below. And now you got your final answer. All right. Bingo. That's how we'd write it. Sometimes they write it in the more expanded form where they have two different negative 4 plus 2 root 2 over 5 and negative 4 minus 2 root 2 over 5. You can look at the notes to see how I wrote that out there. But I want to get through one more example before this video the time gets away from us here. So we want to get this last example in before it gets too long. This last example is a nice one because we're going to have complex solutions to it. And that's what happens now. Since having covered the complex numbers, we can have equations that have complex solutions. That is, the I is going to show up. All right. Now, just like the previous problem, oops, there's a square on that. Just like the previous problem, we're going to get rid of that 59, move it out of the way to begin with so we can isolate the squared piece there. Again, not too hard to do that. So that gives us this 21y minus 14 squared equals negative 54. Now we'll take the square root of both sides. That gets rid of the square on that parentheses, just leaving us the stuff inside. On the right side, you got plus or minus the square root of negative 54. Okay, now you want to simplify that radical. Remember how a 54 breaks down. A 54 consists of a 9 times 6. 9 times 6 there. And so what happens when you simplify that square root? Well, two things are going to go on. The square root of 9 comes out as a 3. The 6 is staying put. And then remember what happens to the negative sign. It turns into an I. And we're going to put it right there before the radical, because that's where it goes. If you have a square root in your answer, you put the I before the radical. All right, there's the simplification of square root of negative 54. Now, continue on to get the y by itself. Move the 14 over by adding it to both sides, and then divide both sides by 21. Again, not too hard to do that. Just add 14 to both sides. And then we'll divide both sides by 21. All right, dividing both sides by 21 here. Now, at this point, we've got to do one extra step that's going to be different from the previous problem. The previous problem had no I in the answer. It was real valued. This problem, since it's got a complex number that has got the I in there, you have to put the answer in standard form. Now, let me just jog your memory about what standard form looks like. Standard form for a complex number is the A plus BI. Remember that? We talked about standard form being A plus BI. There it is. We want to do that here. So how does that work? Just like those problems we were doing when we work on the complex numbers, the division, we break it up into two separate fractions. So you write this as 14 over 21 plus or minus 3i root 6 over 21. And then you reduce these fractions. So the 14 over 21 is going to reduce to 2/3. The 3 and the 21 cancel there, leaving you just a 7 down below, root 6 on top. And then there's I. The I goes off to the right of a fraction. In other words, if the b in your complex number is a fraction, the I goes off to the right of it there, like you see there. And so that's how we put the answer in standard form. So if you got an I in the answer, you got a complex number for an answer, then you want to put it in standard form by breaking up into two separate fractions. And that's what we did when we were working with the complex number, particularly the division problems. We saw that. All right, now it's time to move on to the quadratic formula, which I'll do in the next video.